Okay, next up is our rational graph, or our rational function. Sometimes you'll hear this called the reciprocal function as well. Either one is really appropriate here. The parent equation is y equals 1 over x. The domain and range. So one of the interesting things that you hopefully recognized in this graph was that there were asymptotes at y equals 0 and x equals 0. And I've included those on my graph so you can see them. So as far as our domain goes, we have to say that it'll be all numbers except for 0. So the way we write that is it's all numbers from negative infinity up to but not including 0, and then all numbers not including 0 but after 0 up to infinity. Our range is going to be written exactly the same way because, once again, the y value that we can't use is 0. There's an asymptote at 0 for y, so it's negative infinity to 0 and 0 to infinity. As far as x and y intercepts go, well, there aren't going to be any because we have those asymptotes that are along the x and y axis. Now, as far as interesting properties go, there are asymptotes at y equals 0 and at x equals 0. Our locator point, because we called it a vertex in a lot of other graphs, but our locator point for this one we could still say is 0, 0. And the reason I'll say that is that locator point, which I'll put on the graph here, really shows you where your asymptotes are going to intersect. So the locator point you can think of as the intersection of the asymptotes. And that can help you, if you move your graph left or right 3 units, then your locator point where the asymptotes are going to intersect is going to move left and right 3 units. So that can help you identify where the asymptotes are going to be. And then from there, really there's only a couple points that I would maybe worry about graphing, and that would be 1, 1, and negative 1, 1. I put the rest of them on here just as reference, but those are really the only 2 points that are necessary, because at that point, once you know 1, 1 and negative 1, 1, and if you have any kind of stretch, those points will be affected. But once you know where they are, then you can sketch in the rest of the graph knowing that it's going to just follow along the asymptotes. So this part of my function is just going to continue to follow along the asymptotes. It's never going to cross. So if I know I have this point here, then I know that I can draw the rest of this curve in just so that it stays close to the asymptotes.